The third type is, so first type was when u given, v given. The first type was when u was given or the real part was given, we have to find the analytic function. Type 2 was when the imaginary part, that is v, was given, then we calculated the analytic function. Now type 3 is when u plus v or u minus v is given, how to find the analytic function. Okay, the third type is we are going to calculate the analytic function when u plus v or u minus v is given. So what we have to do is, now normally when u is given, we calculate ux u1. When v is given, we calculate vx and vy. Now when u plus v or u minus v is given, so we have to follow a particular procedure. For that, now we know that f of z is equal to u plus iv. We normally denote f of z by u plus iv. Okay, so what will be I into f of z? If I multiply by I, what will happen? I will get, if I multiply this function f of z by I will get I into f of z is equal to I into u plus I square into v. But I square is minus 1. ठीक है? तो मैंने क्या किया है? F of z is, we know it is equal to u plus iv. So I multiplied, just to get u plus v or u minus v, we are doing this step. Okay, so multiplying by I this function, so we will get I into u plus I square into v, but I square is equal to minus 1, that is v. So now we have to add these two equations. Okay, so start with f of z equal to u plus iv, calculate I into f of z, now add both. So when we add, we will get f of z plus I into f of z. Here I will get u plus iv plus iu minus v. So I am adding left hand side and right hand side, adding both the equations. Now here f of z is common, so I can take f of z common. I will get 1 plus I into f of z is equal to. Now on the right hand side, you are having a real part and imaginary part. So combining the real parts and imaginary parts. So the real part is u minus v and imaginary part is u plus v or v plus u. Okay, so what we are starting with f of z, calculating I into f of z, adding both, and then taking the common term f of z common on the left hand side and right hand side, collecting the real and imaginary part. So now what we will do is, we will denote the left hand side by capital F of z and u minus v as capital U and u plus v as capital V. Okay, so we will denote 1 plus I into f of z by capital F of z, u minus v by capital U and u plus v by capital V, where capital U is u minus v and v is equal to u plus v and capital F of z is equal to 1 plus I into f of z. ठीक है, क्लियर यहाँ तक? तो हमने स्टार्ट किया है f of z. Why we are doing this step? Just to get u plus v and u minus v. Okay, so we are starting with f of z, multiplying by I on both the sides. We get I f of z is iu minus v, adding, then we get 1 plus I f of z is, the real part is u minus v, imaginary part is u plus v, and then denoting the left hand side by capital F of z. Now here capital U and capital V. Okay, this is the first step. So whenever you are given problems of the type u plus v or u minus v, you write these steps. Okay, 2 or 3 steps are required to write what is capital F of z. Okay, so now I hope you have taken down this. This has to be there before solving these type of u plus v or u minus v problems. Okay, so whenever you are having u plus v or u minus v, you have to always write that in terms of capital. We have one more method, I'll show you in the end that also. So whichever method you feel it. Okay, repeat. Start करना है f of z is equal to u plus iv. Okay, f of z is u plus iv. Multiply this equation by I. इसको अगर I से multiply किया तो I will get I into f of z is equal to iu minus v. Then adding both the equations and then taking f of z common on the left hand side, on the right hand side collecting the real and imaginary part, replacing the real part by capital U imaginary part by capital V and the left hand side by capital F of Z. Okay, so that has to be done first. Now, depending upon now what is given, अगर u plus v दिया है problem में, which means that capital V is given. Okay, if u plus v is given in the problem, which means that capital V is given. And if capital V is given, calculate Vx, Vy, substitute in f dash of z, put x is equal to z, y equal to 0. Everything is the same procedure. हमें खाली u plus v और u minus v को u और v में convert करना है. Not same u and v, but you are having capital U and capital V. Then once it reduces to capital U and capital V, now the method remains the same. If u is given, you will calculate ux, then put x is equal to z, y equal to 0, then calculate uy, put x is equal to z, y equal to 0, f dash of z. Everything, whatever we have done in previous two lectures, the same thing will be followed for capital U and capital V. That is only the difference. बाकी कुछ change नहीं है इसमें. ठीक है? So we'll just move for the first problem. U minus v is equal to x minus y into x squared plus 4xy plus y squared. लेकिन वो जो स्टेप है स्टार्टिंग वाला वो लिखना इंपॉर्टेंट है. You have to write the starting step. U minus v is equal to x minus y into x squared plus 4xy plus y squared. तो यहाँ पे u minus v दिया हुआ है. So we will start again with f of z. The same way whatever we have written in the first slide वही हमको यहाँ पे repeat करना है फिर से. f of z को u plus I into f of z, adding everything is same. ये पूरा स्टेप रिपीट होगा जब भी u plus v और u minus v के प्रॉब्लम पूछे जाएंगे. ठीक है? तो अभी हमको क्या दिया हुआ है, यहाँ पे कैपिटल u दिया है, कैपिटल v दिया है. We are given u minus v. Now u minus v we have denoted it by capital U. क्वेश्चन में u minus v दिया है और हमने यहाँ पे u minus v को capital U डिनोट किया है, which means that capital U is given as x minus y into this. This is the same step what we had in the previous slide. तो अभी यहाँ पे हमको u minus v दिया है, मतलब capital U दिया है. So in the next step I will write capital U is equal to. ठीक है? जो पहले जो स्टेप्स थे वो सेम जो हमने पहले किए वही है. तो यहाँ पे now since u minus v is given from the previous step, I will get capital U is equal to that. Now the same procedure what we have done for real part, imaginary part जो अभी तक हमने किए वही मेथड फॉलो करना है. तो calculating f of ux, calculating ux. ux का मतलब है कैपिटल U को x से डिफरेंशिएट करना है पार्शियली. Again I have two bracket terms, so I have not opened the bracket. I have just used u into v. ठीक है? Normally जब भी bracket term है, I am not trying to expand that. If it is बहुत सारे terms आ जाएगा expand किया तो I am avoiding that. So what I am doing is I am writing I am using u into v. The first function u into derivative of second bracket term with respect to x. तो क्या हो जाएगा 2x plus 4y plus second bracket term or v into derivative of x minus y with respect to x will be equal to 1. So I have written x square plus 4xy plus y square. ठीक है? u into v मैंने अप्लाई किया है, मैंने इसको एक्सपेंड नहीं किया है. First function derivative of second function derivative of first, u dv plus v du. Now don't simplify, put x is equal to z, y equal to 0. Now the same procedure we are having, whatever we have done in previous two lectures. So what is capital Ux will be at the point z comma 0, क्या आएगा आंसर? Put x is equal to z and y equal to 0. What will be Ux, capital Ux? तो ux क्या हो जाएगा? x के बदले अगर z पुट किया तो यहाँ पे z माइनस 0 तो z बचेगा. यहाँ पे 2z प्लस 0 तो 2z बचेगा. प्लस x के बदले z है तो z स्क्वायर रहेगा. यहाँ पे y 0 है, यहाँ पे y 0 है. तो आई विल गेट ux इज इक्वल टू 3z स्क्वायर प्लस z, 2z स्क्वायर प्लस z स्क्वायर. which is equal to 3z square. Okay, so ux, capital Ux, it's not small ux in this case, it's capital Ux, where capital U is u minus v. Ux at z comma 0 is 3z square. Simplifying matlab, which one you simplify? You open the bracket, you're saying, yes? Answer will be same. See, this is one of the method. Ux ka last equation. See, answer will be the same. This is one of the method. What I am doing it like this. You can have any method. हमें खाली differentiate करना है और कुछ नहीं करना है. Okay. Okay. तो हमें ux हो गया 3z square. Now calculate uy. मैंने सिंप्लीफाई, मैंने क्या किया, मैंने उसको वैसे का वैसे ही रखा है, u into v अप्लाई किया. You can do it in any manner. Again u into v. यहाँ पे भी मैंने फिर से इसको y से डिफरेंशिएट करना है. तो फर्स्ट फंक्शन डेरिवेटिव ऑफ द सेकंड ब्रैकेट टर्म विद रिस्पेक्ट टू y विल बी, दिस इज 0. 4xy का डेरिवेटिव हो जाएगा 4x, y स्क्वायर का डेरिवेटिव 2y प्लस सेकेंड फंक्शन इनटू डेरिवेटिव ऑफ x माइनस y विच इज -1. तो यहाँ पे मैंने पूरा माइनस साइन कर दिया है. ठीक है, वन स्टेप आई हैव स्किप्ड ओवर हियर. आई हैव नॉट शोन दैट इनटू -1 वाला मैं डायरेक्टली लिख दिया यहाँ पे. ठीक है, तो अगेन पुट x इज इक्वल टू z, y इक्वल टू 0. पुटिंग x इज इक्वल टू z, y इक्वल टू 0. तो ये हो जाएगा z, दिस इज 0. ये हो जाएगा 4z, दिस इज अगेन 0 माइनस z स्क्वायर. अगेन दीज टू टर्म्स आर 0. ओके, सो अगेन 4z square minus z square, that will become 3z square. Now the procedure is remaining the same. Only thing, it is capital U. Okay, so we have got capital Ux as 3z square, capital Uy as 3z square. Both are same. Now substituting in capital F dash of z. Okay, so first now we will calculate capital F dash of z. So here capital F dash of z, the same way we will get ux plus I into everything is same. हर एक चीज कैपिटल लेटर्स में आ जा रहा है और कुछ फर्क नहीं है. Only x y z will be in the small one. Otherwise f dash of z, capital F, capital U, capital V. फिर से we know ux and uy. We are not having vx with us, so we will use CR equations and convert vx to minus uy. ठीक है, तो हमें क्या करना है, यहाँ पे हमको ux पता है लेकिन vx नहीं पता है, because we are having ux and uy. So now we are converting vx to minus uy. So I've written vx as minus uy, substituting for ux and uy. Substituting for ux and uy. So 1 minus I is, or 3z square is common. I can take 1 minus I into 3z square. Now this is capital F dash of z. So integrating capital F dash of z, I will get capital F of z is equal to 3z square का integration करना है, because 1 minus I is the constant. 3 into 1 minus I is the constant. Z square का integration, that will become z cube by 3. ठीक है, तो capital F of z हो जाएगा 1 minus I into z cube. 1 minus I into z cube. 3 will get cancelled. 1 minus I constant will remain as it is. ठीक है, अभी हमें f of capital F of z को small f of z में replace करना है. So what we have taken capital F of z in the first slide. हमारा क्या था capital F of z? We had replaced 1 plus I small f of z by capital F of z. स्टार्ट किया था हमने क्वेश्चन, हमने क्या लिखा था, f of z लिखा था, I f of z लिखा था, देन हमने ऐड किया था, फिर हमने 1 plus I into f of z को कैपिटल f of z लिखा था. तो यहाँ पे भी कैपिटल f of z will replace it by 1 plus I into f of z. है ना, ये हमारा सब्स्टिट्यूशन था जो हमने स्मॉल f को कैपिटल f में लिखा था. तो रीराइटिंग अगेन f of z in terms of this. Now calculate, because our aim is to calculate small f of z only. Okay, we are converting to capital F and then converting to small f. इसके वहां से f of z निकालना है. So what I've taken capital C over here. When I divide by 1 plus I will get C upon 1, capital C upon 1 plus I, that is again a constant. So I've taken it as small c. ठीक है? Or you can take it as C1 and C2. If you're confused, you can take C1 and C2. मैंने यहाँ पे कैपिटल C रखा है जब कैपिटल F of Z को डिफरेंशिएट इंटीग्रेट किया है. उसके बाद now we have to divide throughout by 1 plus I because our aim is to get F of Z, small f of Z. तो ये आ जाएगा कैपिटल C upon 1 plus I. Capital C upon 1 plus I is again a constant. So I have to get a small c. Okay, if you're confused, you can take C1, C2 also. It's only a constant thing. Okay? Now I told you that day also we should not keep any complex number in the denominator. So multiply and divide by the conjugate of the denominator to get the denominator as a real number. We cannot leave the answer in this form because we have a complex number in the denominator. So हमें क्या करना है? Multiply and divide by the conjugate. So 1 plus I का conjugate है 1 minus I. So I'm multiplying and dividing by the conjugate. Now simplify the numerator and denominator. That will be the final answer. Okay, so everything is same. Only thing we are calculating first step है उसमें से हम u minus v को capital U में लिख रहे हैं और u plus v को capital V में लिख रहे हैं. We are calculating capital F dash of Z, capital F of Z, and then converting capital F of Z to small f of Z. ठीक है? तो कितना हो जाएगा ये constant when I simplify? Denominator is a plus b into a minus b, a square minus b square. तो क्या बचेगा denominator में? a plus b into a minus b is a square minus b square. तो क्या बचेगा denominator में? 2. Because I will 1 minus I. Denominator बचेगा 1 plus I into 1 minus I, which is 1 minus I square. Tanya, mute yourself. So denominator is 2. तो न्यूमरेटर क्या हो जाएगा? 1 minus I the whole square. 1 minus I the whole square को अगर एक्सपैंड किया तो I will get 1 minus 2I plus I square. 1 minus 2I plus I square. ठीक है? A minus B the whole square अगर एक्सपैंड किया तो 1 minus 2AB A square minus 2AB plus B square. So I will get 1 minus 2I plus I square. I square is minus 1. So I'll get 1 minus 2I minus 1 upon 2, which is equal to 1 and minus 1 will get cancelled. So minus 2I upon 2 into Z cube plus C. 2 also will get cancelled. So I will get f of Z to be equal to minus I Z cube plus C. Okay? Clear all of you? U plus V और U minus V अगर दिया है, कुछ डाउट है इसमें? You have doubt, please you can ask. Okay. So these 4 types are there. One is U given, V given, U plus V or U minus V. One last question I have, I'll show you one more method. Okay, that is by same method you can do other problems if it comes, but mostly they will not ask, only these 4 types will be asked. U plus U will be given or V will be given or U plus V or U minus V. Okay. Don't keep any complex number in the denominator. Take the next question. U minus V is equal to sin x plus sin hy upon cos hy minus cos x. U minus V is equal to sin x plus sin hy upon cos hy minus cos x. So जब भी U plus V and U minus V is given, we have to write those steps. F of Z equal to I into F of Z. वो लिखना है. हमेशा ये problem solve करने के पहले you have to write those steps. So U minus V is equal to दिया हुआ है. So we'll start with F of Z. I f of z, 1 plus I, then capital F of z. Okay, these steps are to be written whenever you are solving u plus v or u minus v. Okay, so what is given here? Again we are given u minus v, मतलब हमने u minus v को capital U लिया है, which means that capital U is given as the problem. Okay, since we are given u minus v and since u minus v we have taken it as capital U, which means that capital U is equal to sin x plus sin hy upon cos hy minus cos x. So in the next step, capital U is equal to, again calculate ux, uy, put x is equal to z, y equal to 0, same procedure. Almost similar problems only we are having also, not much different problem. जो भी हो हमें differentiate करना है, put x is equal to z, y equal to 0 and calculating ux, uy. ठीक है, तो यहाँ पे u by v दिया है, तो u by v में again calculate ux, differentiating u partially with respect to x, keeping y as a constant. We have applied the u by v method. So v into du. U का derivative with respect to x. Sin hy is the constant. Sin x का derivative cos x minus u into derivative of the denominator, which is minus cos x का derivative, that is plus sin x upon v square. Again, I am repeating, please don't write u dv minus v du. There is a common mistake we find in the paper. It is v du minus u d. बहुत हमेशा ये मिस्टेक बच्चों के होते हैं. u by v का जो फॉर्मूला है, it starts from v. v du minus u dv upon v square. Okay, we have used v du minus u dv upon v square. What is that? Putting x is equal to z, y equal to 0. Put x is equal to z, y equal to 0. क्या बचेगा ux में? Again cos h0 we know it is equal to, cos h0 की वैल्यू 1 है, sin h0 की वैल्यू 0 है. So when I put cos hy, cos y as 0, cos h0 will become 1. तो यहाँ पे हो जाएगा 1 minus cos z into cos z minus sin z, this is 0 into sin z upon 1 minus cos z. So if I replace x as z and y as 0, so cos h0 1, cos z, now here sin z, this is 0 into sin z, so I have written sin square z. Now simplify. Why we need to simplify over here? Because we have to integrate it in the end. So try to get a simplified form so that integration becomes easy. So now open the bracket. So I'll write cos z minus cos square z minus sin square z upon 1 minus cos z the whole square. Okay, cos z minus cos square z minus sin square z upon 1 minus cos z the whole square. I'll combine the second and third term by taking minus sign common. So cos z minus of cos square plus sin square upon 1 minus cos z the whole square. Cos square plus sin square will become 1. So I will get cos z minus 1 upon 1 minus cos z the whole square. Okay? तो मैंने कुछ नहीं किया है, खाली u by v अप्लाई किया है यहाँ पे और x को z पुट किया है, y को 0 पुट किया है, and then we are simplifying, trying to reduce it to a simplified form so that we can integrate it easily in the end. So again यहाँ पे है cos z minus 1, यहाँ पे है 1 minus cos z. So I can cancel if I take minus sign outside from the numerator. So I will take minus sign outside and then cancel 1 upon 1 minus, that is 1 minus cos z in both numerator and denominator. So I'll be left with minus 1 upon 1 minus cos z. ठीक है? cos z -1 है, तो न्यूमरेटर से मैंने -1 कॉमन निकाला है. So when -1 comes out, I will get 1 minus cos z. That 1 minus cos z and 1 minus cos z in the denominator will get cancelled. The remaining will be -1 upon 1 minus cos z. So again, we have used this formula many times. What is 1 minus cos z? One minus cos 2 theta. Yes. 1 minus cos 2 theta is 2 sin square theta. 1 minus cos 2 theta. अगर यहाँ पे 2 है तो 2 cos 2 sin square theta. But यहाँ पे 2 नहीं है. So 1 minus cos z will become 2 sin square z by 2. Okay. 1 minus cos theta will be 2 sin square theta by 2. So here I will write -1 upon 2 sin square z by 2. अगर यहाँ पे 2 थीटा है तो यहाँ पे थीटा आता है. तो यहाँ पे z है तो यहाँ पे z by 2. So now -1 by 2, 1 upon sin square will become cosec square z by 2. So -1 by 2 cosec square z by 2. This is our ux. In the same way, calculate uy. तो ux जैसा हमने किया है वही मेथड से हमें uy करना है. u by v फॉर्मूला यूज करके put x is equal to z, y equal to 0 and then calculating the function uy. Okay, so uy will be again differentiating u by v form. So v du. तो फिर से denominator v, derivative of u, which is sin x is a constant, sin hy का derivative cos hy. Again I am repeating, there is no minus sign when we differentiate cos hyperbolic और sin hyperbolic. जैसा है वैसे ही आएगा. Minus u into derivative of the denominator cos hyperbolic y का derivative sin hyperbolic y upon the denominator square v square. Again put x is equal to z, y equal to 0. क्या आएगा आंसर? When x is equal to z, y equal to 0, again I will get 1 minus cos z into 1 minus sin hy. Sin h 0 is 0. ये पूरा टर्म 0 हो जाएगा. So we will have only 1 minus cos z upon 1 minus cos z the whole square, because sin hy h0 की वैल्यू 0 है. ये पूरा टर्म 0 हो जाएगा. So here I'll get 1 minus cos z into 1, that is 1 minus cos z, which can be written as 1 minus cos z. 1 minus cos z. So 1 minus cos z, as in the previous step, previous ux, we can simplify that to 2 sin square z by 2. Again 1 by 2 sin square z by 2 will become 1 by 2 cosec square z by 2. Cosec square z by 2, yes. uy is equal to. So ux was minus half cosec square z by 2 and uy we have got half cosec square z by 2. Substitute everything in f dash of z. Substituting everything in f dash of z. So f dash of z again ux plus ivx. We cannot keep it in the same form because ux और vx हमें नहीं पता है. हमें खाली ux और uy पता है. That is why we are converting vx to minus uy and then substituting for ux and uy. Ux was minus half, uy was plus half, and already you have a minus sign here. That is why minus I into half cosec square z by 2. So I can take minus half into 1 or minus half cosec square z by 2 can be taken common. So I can write minus half तो यहाँ पे 1 बचेगा, यहाँ पे प्लस आई हो जाएगा इंटू कोसेक स्क्वायर जेड बाई 2. Minus half into 1 plus I is again a constant. You don't have to bother about that. Just integrate cosec square z by 2. So cosec square z by 2 का integration minus half into 1 plus I is the constant which can be taken out. Integration of cosec square z by 2. See, I have taken capital C here also. See, whenever I am integrating f of z, I am taking it as capital C. Okay. तो अभी cosec स्क्वायर का इंटीग्रेशन है माइनस कॉट z बाई 2 अपॉन हाफ भी आ जाएगा बिकॉज z बाई 2 का जो कोएफिशिएंट है. तो आई विल गेट माइनस दैट इज हाफ 1 प्लस आई माइनस cosec स्क्वायर का कॉट z बाई 2 अपॉन 1 बाई 2. अगेन 1 by 2 will get cancelled. I will have 1 plus I into cot z by 2. है ना? Cosec square z by 2. Cosec square z का minus cot z है. तो cosec square z by 2 का minus cot z by 2 upon half. So this half and this half will get cancelled. 1 plus I into cot z by 2 will remain. Now I can replace capital F of z by 1 plus I. Small f of z. So now I will divide throughout by 1 plus I. So this 1 plus I, this 1 plus I will get cancelled and capital C can be replaced by small c. Or C1 and C2 you can take. ठीक है? So small f of z is equal to cot z by 2 plus c. Hope all of you are following this step. Milne Thomson Method, quite simple. Derivative करना और integration करना है in the end. Formulas mix नहीं होने, but that is only the thing to be taken care. Okay. Go to the next question. Q plus V equal to. U plus V is equal to x upon x square plus y square. Okay. Again the same step since U plus V is given. फिर से वही स्टेप फिर से लिखना है अपने को. So now you need not write in every problem. I'm just showing you here. But in the exam, there is only one problem of this type. So you have to write these steps. यहाँ पे मैंने दिखाया लेकिन बार-बार लिखने की जरूरत. You need not write it now. For time being, you can just take. तो हमें क्या दिया? U plus V दिया हुआ है ना. If U plus V is given, we have replaced U plus V by capital V. So which means that capital V is given. Okay. So which means capital V is equal to x square plus y square. Last step of 10th slide. What is the last step? यहाँ पे मैंने क्या किया? I have integrated this. Okay, f of z when I got cot z by 1 plus I into cot z by 2 plus some constant. I have taken that constant as capital C. Okay, I have taken the constant as capital C. Now replacing capital F of z by 1 plus I into small f of z. Now divide throughout by 1 plus I. Divide throughout by 1 plus I. So I will get f of z here. Here I will get cot z by 2. Here I will get capital C upon 1 plus I. So capital C upon 1 plus I is again a constant which I have denoted it by small c. ठीक है? You can take it as C1, C2, जैसे भी constant is having. आया समझ में सर्वज्ञ? Did you understand now? I'm dividing throughout by 1 plus I. So last step will be C upon 1 plus I. So C upon 1 plus I is also a constant. So I have replaced that capital C by small c, where small c is capital C upon 1 plus I. Okay. Yes. So we'll go to the next question. This is already, I told you the first step. We'll skip this step. Yeah, we'll start from here. So v is equal to x square plus y square. This was the problem given. Okay. I have written those steps again, which we have written for all the problems. That I'm skipping it. I'm coming directly to capital V equal to. But एग्जाम में लिखना ही है वो स्टेप. Okay, don't forget about that. ठीक है. तो v हो गया. Now calculate vx. फिर से u by v अप्लाई करना है. vx v into du. x का डेरिवेटिव 1 minus x into 2x upon x square plus y square the whole square. ठीक है. v into derivative of u minus u into derivative of v upon v square. Put x is equal to z, y equal to 0. What will be the function vx? When I put x is equal to z, y equal to 0, okay, minus 1 by z square. Okay, let's check that. तो हमें क्या करना है? Put x is equal to z, y equal to 0. क्या simplified here? अगर नहीं भी simplify किया है तो I'll get here z square plus 0 minus 2z square. So z square minus 2z square will become minus z square. So I'll get minus z square upon denominator will be z square the whole square, which is z raised to 4. That is minus 1 upon z square. Okay. Correct. So minus 1 upon z square. Similarly, calculate vy. Similarly, calculating vy. सेम में u by v अप्लाई करना है, लेकिन now when you apply u by v, x का डेरिवेटिव 0 हो जाएगा, है ना. When I apply u by v here, v into du, derivative of x with respect to y will be 0, minus x into dv, that is 2y upon v square. So vy is equal to 0. Yes, because the first term is 0, second term has y in it. So the both terms will become 0. So vy is equal to 0. You follow whatever methods of differentiation you have done. Okay, I'm just showing my method. Whichever method you can even take x common, then derivative of 1 upon x square plus y square. Okay, you can use u into v, or there are different ways of simplifying. But normally what I do is if u into v is given, apply u into v and u by v, so confusion nahi hai. If you can do it simplified form, you just differentiation has to be correct. That is only important. So ठीक है, vx is minus 1 by z square, vy is 0. Substituting everything in capital F dash of z. Now we are knowing vx and vy. Ux is not known to us. So we have to use CR equation and replace ux by capital Vy. So replacing ux by capital Vy, f dash of z will become Vy plus I into Vx. Vy we got it as 0. Vx we got it as minus 1 by z square. Vy is 0, Vx is minus 1 by z square. So I will get Vy के बदले 0 हो जाएगा plus I into Vx is minus 1 by z square. Integrating minus 1 by z square का integration is 1 upon z, है ना. Minus z raised to minus 2 हो जाता है, तो minus 2 का integration minus 2 plus 1 upon minus 2 plus 1. That will become 1 upon z. And again I've taken capital C here. Now replace capital F of z by small f of z. So 1 plus I into small f of z is equal to I into 1 by z. So small f of z अभी क्या होगा? Dividing throughout by 1 plus I. So f of z हो जाएगा I upon 1 plus I into 1 by z plus capital C upon 1 plus I. Again capital C upon 1 plus I can be replaced by small c. So I'll write f of z be equal to I upon 1 plus I into 1 by z plus small c, where small c is capital C upon 1 plus I. Now again we have a complex number in the denominator, multiply and divide by the conjugate and get Just simplify. You should always have denominator as a real number. So multiplying and dividing by the conjugate of the denominator. So 1 plus I का conjugate 1 minus I. So again denominator will be 2. Numerator में क्या होगा अगर I को अंदर लिया तो I into 1. That is I. I into minus I will become minus I square. Minus I square is equal to plus 1. So I will get 1 plus I upon 1 minus I square, that is equal to 2 into 1 by z plus c, small c. Okay? सेम ही है, खाली एक फर्स्ट 4 स्टेप्स है वही एक्स्ट्रा लिखना है, बाकी हम कैपिटल एफ ऑफ जेड फॉर्म में स्मॉल एफ ऑफ जेड में लास्ट में रिप्लेस करना है. In final answer, in numerator complex term, if it is there, numerator में चलते that we cannot simplify the numerator part, no, we cannot do anything. Denominator we can multiply and divide by the conjugate, because if you do the same thing in the numerator, then the denominator will become a complex number. We have to see that denominator has to be a real number, numerator you can have a complex number, there is no issue in that. Okay? But denominator you should not leave the answer in terms of a complex number. That is only important. 1 plus I or I can be there in the numerator, because x plus I जब लिखते हैं तो I numerator में ही होता है, denominator में नहीं होता है. When you write any complex number x plus I is there is always in the numerator. Okay? Yes. The next problem, u plus b is equal to e raised to x into cos y plus sin y plus x minus y upon x square plus y square. Again u plus v given, मतलब what is given, u दिया है कि v दिया है, capital U और capital V is given. If I write those steps again and again, what is given, that means capital V is given, correct. Capital V is given. So I'll skip those steps, whatever within the first one. Okay? Because we already know what is the step. I'm not repeating it again. So we'll start with capital V is equal to. Yes. Capital V is equal to. Again use Vx, calculate Vx, Vy, put x is equal to z, y equal to 0. Differentiate. Tell me what will be Vx at z comma 0. Now when I calculate Vx, तो यहाँ पे दो functions हैं. Okay, u into v we can apply, but here cos y plus sin y is the constant with respect to x. तो ये पूरा टर्म वैसे का वैसे ही रहेगा, e raised to x as it is यहाँ पे आ जाएगा. यहाँ पे u by v अप्लाई किया है, तो v into du minus u into dv upon v square. Again don't simplify, put x is equal to z, y equal to 0. Tell me what will be the answer. फर्स्ट टर्म में क्या बचेगा, अगर मैंने x को z पुट किया और y को 0 पुट किया, तो यहाँ पे e raised to z हो जाएगा, cos 0 is 1, sin 0 is 0. So I will have only e raised to z in the first term. Second term, यहाँ पे z square minus 2z square. So z square upon, so I think I'll get e raised to, when I put x is equal to z, I'll get e raised to z here. यहाँ पे एक z स्क्वायर होगा और यहाँ पे एक माइनस 2z स्क्वायर होगा. So z square minus 2z square will become minus z square upon z raised to 4, which is e raised to z minus 1 upon z square. ठीक है, dx is equal to e raised to z minus 1 upon z square. Similar way, calculate vy. कैलकुलेटिंग वी वाई। खाली हमें वो फॉर्मूला यूज करना है, u इंटू वी हो या u बाई वी हो, उसको फॉर्मूला यूज करो, कुछ सिंप्लीफाई मत करो। पुट अगेन दिस स्टेप इज नॉट रिक्वायर्ड व्हाट आई रिटन ओवर हियर, यू कैन डू डायरेक्टली ऑल्सो। ठीक है, मैंने सिंप्लीफाई करके लिखा है लेकिन जरूरत नहीं है। u इंटू वी या u बाई वी बराबर करना है, उसके बाद पुट x इज इक्वल टू z एंड y इक्वल टू 0। ठीक है, तो वी एक्स इज ई रेज टू जेड, वी वाई क्या होगा। वी वाई में अगर हमने फर्स्ट टर्म को डिफरेंशिएट करना है तो ई रेज टू एक्स विल बी अ कांस्टेंट, ब्रैकेट टर्म का डेरिवेटिव हो जाएगा माइनस साइन वाई प्लस कॉस वाई, कॉस वाई का डेरिवेटिव माइनस साइन वाई का डेरिवेटिव कॉस वाई, तो आई विल गेट वी वाई। यहाँ पे फिर से यू बाई वी अप्लाई करना है, तो आई विल गेट ई रेज टू एक्स इज अ कांस्टेंट, आई कीप इट एज इट इज, इसका डेरिवेटिव इज माइनस साइन वाई प्लस कॉस वाई, देन अगेन यू बाई वी, so v du derivative of x minus y with respect to y is minus 1 minus x minus y into 2y upon x square plus y square the whole square. Put x is equal to z, y equal to 0. तो यहाँ पे e raised to z हो जाएगा, this will become 0, this will become 1. So first term will reduce to again e raised to z. यहाँ पे क्या बचेगा, ये पूरा टर्म 0 हो जाएगा बिकॉज वी आर हैविंग y इन द सेकेंड टर्म, so in the first term only minus z square upon z raised to 4, same term you will get, है ना, e raised to z minus 1 upon z square. Substituting in capital F dash of z, substituting in capital F dash of z, same way ux plus ivx, but ux is not known to us, so we have to use the CR equation and convert ux to vy. So I will get vy plus ivx substitute for vx and vy. Again, e raised to z minus 1 by z square is common term. I can take it out. So I will have 1 plus I into e raised to z plus 1 by. Okay. I've taken common. One step I've skipped over here. 1 plus I is taken, that is e raised to z minus 1 upon z square is taken common. Remaining will be 1 plus I, and the integration of e raised to z minus 1 upon z square. E raised to z integration is e raised to z minus 1 by z square integration is 1 by z. One step I have not shown after taking that e raised to z minus 1 by z square common. Convert this to small f of z. To small f of z, that is 1 plus I f of z. Then divide throughout by 1 plus I. So 1 plus I upon 1 plus I, capital C upon 1 plus I, capital C upon 1 plus I, I'll replace it by small c, and this 1 plus I will get cancelled. So f of z is equal to e raised to z plus 1 by z plus small c. ठीक है, there is one more problem where we are not having any of the above form. This is the only problem available here where we are not having u also, v also, u plus v or u minus v. Okay, तो हमें कैसे प्रोसीड करना है आई विल टेल यू. बाकी अभी तक हमने जितने भी किए वो सेम टाइप के ही थे. u था, ux निकाला, uy निकाला, v था, vx, vy, everything was having the same procedure. यहाँ पे भी सेम है बट स्लाइट डिफरेंस इन कैलकुलेटिंग ux एंड vx. ठीक है, अभी हमें just pay attention here, it's little different, not as the previous one. तो हमारा एम क्या होगा? सबसे पहले वी शुड सी व्हाट वी रिक्वायर. वी वांट टू कैलकुलेट स्मॉल एफ ऑफ जेड. ठीक है, स्मॉल एफ ऑफ जेड निकालने के लिए वी रिक्वायर एफ डैश ऑफ जेड. राइट, वी रिक्वायर एफ डैश ऑफ जेड. टू कैलकुलेट एफ डैश ऑफ जेड वी रिक्वायर यू एक्स एंड वी एक्स, है ना. एनी ऑफ दोज पार्शियल डेरिवेटिव्स आर रिक्वायर्ड, ux vx और uy vy. Anyway we can write that. ठीक है, तो our aim is to get ux and vx or ux and uy, whatever is that. तो our aim will be get ux and vx. ठीक है, तो हमें ये इक्वेशन में से ux और vx कैसे मिले, कब मिलेगा? When will we get ux and vx from this particular equation? Because in the end we have to calculate f of z. Yes, correct. We have to calculate f of z. To calculate f of z, we have to calculate f dash of z. And in the formula for f dash of z, we have ux and vx. So we want to calculate ux and vx. तो ux का मतलब क्या होता है? dou u by dou x. मतलब क्या है? डिफरेंशिएटिंग पार्शियली विद रिस्पेक्ट टू x. तो हम क्या करेंगे? इसको मैं इक्वेशन 1 ले लेती हूँ. इसको नाउ दिस इक्वेशन आई विल डिफरेंशिएट पार्शियली विद रिस्पेक्ट टू x. यस, so we have to differentiate this partially with respect to x. मतलब 3 into u का डेरिवेटिव हो जाएगा ux, v का डेरिवेटिव हो जाएगा vx, y स्क्वायर का डेरिवेटिव 0 बिकॉज हम विद रिस्पेक्ट टू x करेंगे, x स्क्वायर का डेरिवेटिव 2x और इसका डेरिवेटिव 16y. So we are going to differentiate equation 1 with partially with respect to x. Okay, differentiating this, why we are doing partially? Because we require ux and vx. ux is the partial derivative of u with respect to x. ठीक है, तो differentiate किया तो क्या आएगा आंसर? 3ux plus 2vx, ये 0 हो जाएगा, ये minus 2x plus 16y because x derivative is equal to 1. ठीक है, this is one equation. Understood this part? Why we are doing this differentiation? Because we require ux and vx in calculating f dash of z. तो मैंने इसको differentiating equation 1 with partially with respect to x कर दिया. ठीक है, अभी मैं क्या करूंगी? Now here we want ux and vx. So directly we will not get ux and vx from one equation. So we will require one more equation. So differentiate this partially with respect to y now. Differentiating equation 1 partially with respect to y. तो क्या हो जाएगा? 3uy plus 2vy, y स्क्वायर का डेरिवेटिव 2y, x स्क्वायर का डेरिवेटिव 0, 16xy का 16x. ठीक है, तो हमने क्या किया है? Our aim is to get ux and vx. तो हमने पहले डिफरेंशिएशन विथ रिस्पेक्ट टू x किया है, बट विद वन इक्वेशन यू कैन नॉट कैलकुलेट ux and vx. We require 2 equations to calculate ux and vx. So second equation हम कैसे ला रहे हैं? By differentiating this with respect to y. So 3uy 2vy is equal to 2y plus 16x. Now we want to solve for 2 and 3. We want to solve equations 2 and 3. अगर हमें equations 2 and 3 को solve करना है, for what we have to solve? We have to get ux and vx. ux और vx के लिए हमें इक्वेशन सॉल्व करना है. तो these are the, we have to get 2 simultaneous equations in ux and vx. तो पहला इक्वेशन तो एज इट इज रहेगा, इसको भी हमें ux और vx में कन्वर्ट करना है. Now how to? Yes, we have to convert, we have to make use of the CR equations to convert uy and vy in terms of ux and vx. तो मैं क्या करूंगी? थर्ड इक्वेशन में CR इक्वेशन अप्लाई करूंगी एंड कन्वर्ट दैट टू ux and vx. तो क्या हो जाएगा? इफ आई यूज द CR इक्वेशन इन 3, तो ये दिस इज CR इक्वेशन, ये स्टेप मैंने ऐसे कैसे लिखा हुआ है. ठीक है, अभी ये इक्वेशन में व्हाट इज uy? वी नो uy इज इक्वल टू माइनस vx. तो मैं ये जो uy है वो माइनस vx के नीचे लिखूंगी यहाँ पे. ठीक है, एंड vy इज इक्वल टू ux. तो ये जो 2vy है उसको मैं 2ux यहाँ पे लिख दूंगी, तो ये हो जाएगा 2ux. ठीक है, vy के बदले ux मैंने यहाँ पे लिखा है और 3uy के बदले -3vx मैंने यहाँ पे लिख दिया है. ओके, नाउ दीज आर टू साइमल्टेनियस इक्वेशंस इन ux एंड vx, नॉट इन x एंड y, क्योंकि हमें ux और vx निकालना है. So we are not solving these two equations in terms of x and y. We are considering these two are two simultaneous equations in ux and vx. तो अभी हम इसको कैसे सॉल्व करते हैं? नॉर्मली टू साइमल्टेनियस इक्वेशंस इन vx and ux. We use elimination method to simplify those two equations. तो हम कैसे यूज करेंगे इसको? We have to make these coefficients same. तो मैंने क्या किया है? Vx को एलिमिनेट करने की कोशिश की है पहले. For that, I will multiply this equation by 3, the fifth equation by 2 and add. ठीक है? Our aim is to solve these two equations simultaneously for ux and vx. So I am trying to eliminate one of the variables, that is vx. अगर मैंने vx को एलिमिनेट किया तो मुझे इसको 3 से मल्टीप्लाई करना पड़ेगा और इसको 2 से. So what I have done is I have multiplied equation 4 by 3 and equation 5 by 2. So I will get, इसको अगर 3 से मल्टीप्लाई किया तो I will get 9ux, 6vx minus 6x, 16 into 3, 48. इसको हमें 2 से मल्टीप्लाई करना है तो I will get 4x minus 6vx, 32 and 4. ठीक है, अभी दोनों को हमें सॉल्व करना है. तो these two terms will get cancelled. कितना बचेगा यहाँ पे? If I am adding both the equations, these two will get cancelled. So 9ux plus 13, 4ux will become 13ux. How many x here? So I will get 32 minus 6, that is 26x. 48 plus 4, that is 52y. ठीक है, तो हमने क्या किया है? From the given equation, we have differentiated with respect to x to get the first equation in ux and vx. Again with respect to y, so we have got uy and vy. Use CR equations in equation 3 and converted that to ux and vx, solving these two equations simultaneously by elimination method. So I have eliminated vx variable, so I'll get 13ux. तो यहां से हो जाएगा ux is equal to 2x plus 4y. ठीक है, ux is equal to 2x plus 4y. अभी ux मिलने के बाद हम क्या करते हैं नॉर्मली? व्हाट इज आवर प्रोसीजर? Once I get ux, what is the next procedure? Put x is equal to z, y equal to 0. So I will put x is equal to z, y equal to 0. I will get the answer as 2z. ठीक है, अभी हमें क्या निकालना है? vx. तो vx के लिए क्या करना पड़ेगा? Now from the previous slide, to calculate vx from here, what we do? Either you can substitute ux in one of the equations or you can eliminate ux from here. ठीक है, so what I have done is I have substituted, because already we have got ux here, I have substituted ux in the fourth equation. I have substituted ux in the fourth equation because ux is known to us. हमारा ux था 2x plus 4y, उसको मैंने सब्स्टिट्यूट किया फोर्थ इक्वेशन में. So this is after substitution in the fourth equation. Okay, तो अभी इसका आ जाएगा 6x plus 12y plus 2vx is equal to minus 2x plus 16y. यहां से हमने vx निकालना है. So I will get 6x here minus 2x. This 6x will go to the other side. I will get minus 8x. Here 12y minus 12y. 16y minus 12y is 4y. So I will get vx is equal to minus 4x.
Can you see my screen? I don't know what is the problem. I'm not able to share now. That was the last part. Okay, f of z is equal to this. I'm not able to present now.